Hi everyone. So the topic of the demo today is highly available active-active NFS server on GlusterFS storage system. So I am Meghna Madhusudan. I also have Soumya Koduri from the NFS-Ganesha team here at Red Hat. So let me take you through the agenda of today's session. So first I introduce you to what exactly NFS-Ganesha is and what the integration of NFS-Ganesha and GlusterFS means and how it is implemented. And then I move on to the high availability of NFS-Ganesha servers, that is active-active. And then I introduce you to the new CLI commands that we have introduced in this release to make the Ganesha exports and configuring NFS-Ganesha easier. And then we have also implemented a new framework called the upcall infrastructure to support active-active NFS-Ganesha solution. So Soumya is going to take over and explain it to you. And then it also includes a quick demo of a failover scenario where one of the Ganesha heads is killed and IO is in progress, and we see how the IO progresses just the way it should. And Soumya is going to show that to you as well. So let me move on. So what is NFS-Ganesha? So it's a user mode file server. It supports NFS v3, 4.0, 4.1, PNFS, and 9P as well. So it uses something called as Fuse compatible file system abstraction layer called the FSALs to plug into any storage mechanism. So upstream NFS-Ganesha today supports FSALs for GPFS, Lustre, and also Gluster. And we have integrated GlusterFS with NFS-Ganesha using the libgf API library, which is available via GlusterFS API and GlusterFS API devel packages. And to dynamically export and unexport GlusterFS volumes, Ganesha uses something called as debus mechanism. So what do we really mean by dynamic export and unexport? So without having to restart the NFS-Ganesha server, we can actually take out one export or add another export. That is what we call the dynamic exports. So let's move on to the high availability of NFS-Ganesha servers. So how have we achieved it? So we've used something called as Pacemaker and Corosync. So entire cluster. Any NFS server goes down, all the other NFS servers are intimated that one of the nodes has gone down. And we have also implemented a HA script this time, which takes care of setting up the cluster, tearing down the cluster, and it takes a few parameters as the input. So what do you need? We need the servers that you want to be the part of the Ganesha HA cluster. That means to say, so select the server on which you want to run NFS-Ganesha on. So then the nodes need not be every node in the entire cluster. So it could be a subset of the servers, which can go up to 16 nodes, which we have a limitation as of now. And we take this input via a configuration file, and that is called a ganesha-ha.configuration file. I'll show you a sample file a little later. So this script, like I said, it sets up the entire cluster. That means to say, if the nodes are in a cluster and any node goes down, we can identify that the node has gone down and take appropriate steps for failover and lock recovery, etc. So, and we also have resource agents. Without this, we can't have the solution working. So the resource agent actually monitors the NFS server. We have resource agents called Ganesha-Grace, Ganesha-Mon in the Gluster sources that will take care of monitoring the NFS service. And also, it sends a debus signal to the entire cluster. So what happens is, let's consider a case when a Ganesha goes down on one of the nodes, and for correct lock recovery from the client that was connected to that server, we need all the servers in the cluster to be in grace. So that this is done by sending a debus signal, and we induce a grace in each of the other servers that are up and running. And then we have the virtual IP failing over from one node to the next node. So we have a list of nodes that I have already said as the input. So we assign scores to each of these nodes. So whichever node has the second highest score, that's how failover happens. So I'll show you the config file a little later and explain this a little better then. And then we have integrated with two new Gluster CLI commands to make the configuring easier. So what are the required packages for you to get this new solution? Gluster RPMs greater than 3.7. You need GlusterFS-server star and GlusterFS API and GlusterFS-Ganesha RPMs and the latest NFS-Ganesha RPMs. So one is the normal NFS-Ganesha RPMs without any FSALs. The second one is specific to Gluster. You need to install this as well for Gluster side integration. So since this solution is complex, we need a lot of prerequisites here, and it's very important that these prerequisites are followed in the right order and that it is carried out on each of the nodes that you want Ganesha to run on. So you have to populate etc hosts on all the machines. That means to say all your nodes should be populated in etc hosts, and the same way every other node should have the same file recognizing all the other nodes in the cluster. Then you disable and stop network manager service. The third one is very important. It's the shared volume concept that we require for the correct lock recovery during failover. So we need to store some NFS state. So we have to have a Gluster shared volume called Gluster shared storage. It's mandatory that you use this name because it's a common meta volume used across different features of GlusterFS, and you mount it on var run Gluster shared storage, and this path is also fixed. So this should be mounted on all the nodes that you intend to run Ganesha on, and make sure that you mount this volume only using the GlusterFS native mount. And then touch an empty file etc ganesha.conf. Right now it does not have any parameters, but it is subject to change if you need any global parameters. But right now you can have an empty file in this path. And like I said, we've used Pacemaker and Corosync. So you need to install the following packages to make it work: Pacemaker, CMAN, PCS, CCS, resource agents, Corosync on all the machines. And then you have to have a unique user called HA cluster, so which will help in all the Pacemaker and Corosync related operations. So set the user password, the password for HA cluster to be the same across all the nodes. And the next one is you have to enable IPv6 on the cluster nodes. Then start PCSD on all machines. It's very important you do this. And then populate the etc Ganesha HA conf file. This file is very important to us because this is where you tell us on what nodes you want Ganesha to be running on, and each of these nodes have to be associated with a virtual IP. So let's move on to how this sample file actually looks like. So the first parameter is called a HA name. So this is the name of the Ganesha HA cluster that is created as part of our Ganesha-ha.sh script. So when you set up the cluster, the setup should be given a unique name. That's what you enter in this file. And remember that the name of the file should be unique in the entire subnet. You cannot have two clusters with the same name in the same subnet. And the second one is the HA vault server. So like I said, I had already explained about the shared volume that is required to store some NFS state, right? So you mount that volume using one of the server host names or IP. So whatever you use, we need to know that. Enter that server name here. And then the third one is the list of the cluster nodes. So you want Ganesha to be running on server 1, server 2, server 3. Give a comma separated lists under this. And then it's very important that each of these nodes have a VIP associated with it. That's a virtual IP. So when you mount a volume, make sure that you mount this volume via the VIP that you have designated against this server, so that when Ganesha is killed, this VIP resource is moved to the another VIP resource where Ganesha is already running. So the scores are also given in a way that it's like incremental, starts from 1000, and for the local node the score is the highest, and whenever a server goes down, it checks which is the next highest score. So consider that the local node has a score of 4000 and server 2 has a score of 3000. So when the Ganesha on node 1 with a score of 4000 goes down, the VIP is moved to the server 2 where the score is 3000. So this is how the failover works. Let me introduce you to the new CLIs that have been implemented to make things easier. So it's important that we disable Gluster NFS because you cannot have two NFS servers running on the same node. And also you don't want to end up in a situation where half of the Gluster trusted pool is running Gluster NFS and the rest half is running Ganesha. So the first option takes care of all of these things. It's called Gluster features.Ganesha enable or disable. So what does enable do? Enable actually disables the Gluster NFS across the entire Gluster trusted pool. It asks you whether you want to proceed with it. Only if you say yes will the next steps be carried out. And the second step is it starts the NFS-Ganesha services only on the nodes that you've specified in the previous config file in the HA cluster nodes that you can see. And the last one is setting up the NFS-Ganesha server. So it's a series of PCS commands that will never be exposed to the user that the script takes care of. And your setup is ready to go and you have the NFS-Ganesha service running. But it does not export any volume by default. It just starts a service. If you want to export any volume, you have to explicitly run the next command. It's a volume set command, GlusterVol set vol name Ganesha enable on. So what it does internally is it creates an export config file with the default parameters. This is read by Ganesha, and we also send a debus signal so as to dynamically export this volume. So you have a new export running after this command is executed. And what does Gluster features or Ganesha disable do? So it stops the NFS Ganesha services on all the nodes that you've already started. It tears down the NFS Ganesha cluster. So it stops all the services and all the resource agents that were created as part of this. It tears down the entire thing, brings it back to normal, but then it will not bring the Gluster NFS service back. It just kills the Ganesha service. And what does GlusterVol set Ganesha enable off do? So it unexports the volume. Since the second is a volume set command, it just unexports the volume, keeping the service intact. If you need the entire cluster to be toned down, you'll have to run the first command, giving disable as your value. So if you want to add new nodes to the cluster, it is possible via add node and delete node options in the Ganesha-ha.sh script. We don't have separate CLIs for that. We need a few extra steps for you to add a new node into the Ganesha HA cluster. So that can be done by executing --add and with a new VIP and --delete for on which you want to delete the node. So Soumya will take over now and explain the upcall infrastructure required for active-active NFS-Ganesha. Thank you.
Thank you. In the cluster storage team. So let me first start with what exactly active-active NFS-Ganesha means. So multi-head NFS-Ganesha server, that means that like cluster NFS, Ganesha servers now hosting on different cluster nodes should be able to export the same volumes to their clients. So what are the challenges involved in it? Consider as Meghna has already explained, NFS-Ganesha server provides a FSAL layer using which you can plug into any backend storage system. So it like Gluster. So whenever the NFS client makes any request, sends any request to the NFS-Ganesha server, NFS-Ganesha server internally it sends it to the backend server like Gluster, and after fetching the required data, it most probably it will cache it that to metadata most of the time. So next time when any NFS client makes a request to the Ganesha server, most probably it may be serving the request from its cache instead of sending it all the way till backend server to improve the performance. So what happens in case of multi-head? Suppose now consider a two-node setup and there are two Ganesha servers exporting the same volume. So now the clients connected to it is in case if they are accessing the same volume or same file or a same directory in a volume. So and if Ganesha servers on those two nodes are started serving from their cache, there are high chances that they may see a stale data whenever they make any request. So to avoid that, we needed some mechanism in cluster to intimate those servers whenever there is any change in the backend system for any file or directory which those servers have accessed. So to do that, to achieve that, we have introduced new upcall infrastructure. It is just a file system notification mechanism using which Gluster can intimate its applications, in this case NFS-Ganesha, whenever there is any change in the file system state. So this infrastructure in general, it's a generic and extensible framework. What it exactly does is here the server means the Gluster server and the client means the NFS-Ganesha application, which acts like a Gluster client. So we maintain certain state in each of this cluster server, and whenever there is any change in the state, we intimate the applications or the clients about the change. So one of the use cases of this infrastructure is cache invalidation, and it is required for active NFS-Ganesha, as I have just mentioned. What it does is, for each whenever any NFS-Ganesha head makes any request for any file in or directory in the volume, the cluster server process maintain the state of that particular client. For example, the last time it has accessed that file or directory, and it stores it in its process. So next time when any other client is making changes to that file, since it knows the first client information of which I had accessed it, it will send a notification that the file state has changed and it may has to invalidate its cache. So that's the main purpose of this feature. And so we have introduced two accelerator options, volume level accelerator options to turn on this feature. The first one, Gluster wall set features.cache invalidation on, will enable this feature for that particular volume. And the second option enables admin to set the cache timeout. What exactly cache timeout means is, Ganesha head, as you know, any cache, it has some particular timeout value. Like in case whenever any it caches any data, after certain timeout, it invalidates this cache entry, no irrespective of whether the client makes any request or not, or accessing that particular data or not. So since Gluster server maintains the state of those clients now, whoever are accessing files or directories on its in its volume, it need not intimate those clients whose cache has already been invalidated. That means who has accessed that particular file beyond this timeout value. So to make it configurable, we have introduced this new option. So applications can set this timeout value to the cache timeout of their process, and then can use this feature accordingly. So that's the brief of how active NFS-Ganesha is achieved. And let me just quickly go through and recap how exactly the failover happens. Okay, so let's see. So in the Ganesha server, suppose there are 4 nodes, each having a Ganesha server, and as Meghna has mentioned, let's assume VIPs have, I guess, screen sharing. There is some problem with sharing the full screen. We had some animation, but I'm sorry for the inconvenience. There was some problem with the sharing the full slide. So what exactly we are trying to say is, suppose consider there are 4 nodes and Ganesha server has been we have configured such a way that there is Ganesha server running on all of those nodes. and we have assigned virtual IP, unique virtual IPs for each of those Ganesha servers, and they all communicate with each other using Pacemaker Corosync, as Meghna has already explained, and also they have access to the shared meta volume. Let me just give a brief on how why exactly shared volume is present, because as Meghna had already mentioned, we need that to maintain NFS state. So as many of you may have aware of, NLM and NFS v4 are stateful protocols. That means that NFS server has to maintain certain state of the file of the clients which have accessed the files using that server, and to maintain that state persistently, uh, it uses a location called varlib NFS, and this is configured on each node. So in case of multi-head, whenever any failover happens, so other Ganesha servers on other nodes need to know the NFS client state of the server which had gone down. So to share that NFS state across the all the nodes, we have used shared volume concept, which Gluster has already has. So this shared volume has to be mounted on all the nodes, so that after failover, the other nodes can validate the clients which are connecting to them after the failover. So, and these are more information. Also, you can mail us or reach us on IRC in Gluster Dev and Ganesha channels, and you can mail us it to Gluster Devel or Ganesha Devel. So we shall show a quick demo. Let me connect to the quickly to the setup.
Please bear with the speed as it is VPN connected here.
The IP. Okay, just give us 1 minute. We're just quickly setting up the phone node cluster. Okay. See, this is our 4-node cluster. As you can see, pacemaker. We have used Pacemaker, so you can check the cluster status in using PCS status command. See, currently cluster is not configured. Let's quickly check if NFS-Ganesha has been running. NFS-Ganesha is stopped, and as we already spoke about, shared volume should be mounted. Yes, it's mounted on all the volumes. And there is a prefixed path like var run cluster shared storage where it has to be mounted. And let's look at the sample config file, HA conf file, which has to be provided on all the nodes. As you can see, we have configured RHS 1, 2, 3, 4 and assigned VIPs for each of those nodes. And we have given a unique cluster name. Okay.
If NFS-Ganesha directory is created in var shared storage.
Okay. So one of the prerequisites which Meghna has already mentioned, there should be a NFS-Ganesha directory in var run shared storage. Yes, it's created. So let's see what are the volumes we have. We have a test wall. As you can see, currently upcall feature is off, cache invalidation feature off. Uh, now let's create the cluster. So it prompts us to disable the cluster NFS. So while it creates the cluster, let's log into the client machine. Okay, this is our client. Okay, as you know, Pacemaker, Corosync, it creates so many resource agents and there's so much background services which get started. So it does take some time to set up the entire cluster.
You can check the script that we are going to use.
Yeah. Meanwhile, yeah, we can check the script. I will let you know the so the script location. You can see it is Ganesha ha.sh. This is the script, Ganesha script. This is script need to be used to add and delete a node dynamically at runtime to the cluster. So as you can see, the command has been successful. Let's see PCS status command. As you can see, all the VIPs have been associated. Let's check across all the nodes. Okay, cluster has been configured on all the nodes, and we'll see. Let's see the service NFS-Ganesha status. It's running, and uh, as you can see, virtual IPs have been assigned to each of those nodes, unique virtual IPs. Now, let's try to export a volume. Virtual Ganesha .enable on. Okay. As you can see, test wall is exported. We can check across all the nodes. There has been, I think, as he said, Meghna has already mentioned, Ganesha.conf should be empty before starting the cluster. I guess we may have missed that. Yes, so it wasn't empty. So let me just quickly remove this file and recreate it. So let's disable the, let's tear down and set up again. Okay. Yeah. For the failover, meanwhile, I can show you the script which you are going to use. So we'll mount the volume and we'll just write hello world for around 50 times. In between, while it is writing, we'll kill the Ganesha service on that particular node. So after the IBIP fails over to a next node and after the Ganesha server comes out from the grace, we should see IOs happening post that too, and all the 50 times this string should have got written into the file. So meanwhile, I'll show you the sources. Sorry. I'll enable cluster. So let me just quickly do the cleanup required. This cleanup is required to properly clean up the stale data we may have during the cluster setup, so that we don't get into any problem while recreating the setup.
These manual steps are eliminated in the current release, so you need not do it manually.
Yes. Okay, so okay, so you can see these are the sources. Accelerators features upcall has all the upcall feature related sources, and accelerators features Ganesha has all the Ganesha CLI related code. Yeah. And
Extras
Ganesha has the HA scripts and resource agents which I am using. Okay. So let's do quickly check NFS-Ganesha status again. Yes. Yes, it's running. So now let's enable export the volume. Okay. I guess we may not have done the cleanup properly.
Second, check on some other note.
Okay. So let's quickly show the IP failover. I guess uh, um, okay. Let's do one last time. I shall do the disable. I guess I still feel the cleanup might have not happened properly. Okay, taking certain time. Okay.
Make sure you clean up
everything again. Yeah, group all in tab, and let's go to broadcast all cd/user local libxsec Ganesha. We do cleanup. Yes.
And open the Ganesha config.
Yes. etc Ganesha. Ganesha.conf. You can see it's empty now. No, it isn't empty here.
Yeah.
I guess it's the problem with grouping my tabs here. I'll manually do it on this last node. Local libxsec Ganesha, and then do cleanup. Yes, everything is done. And now let's do the cat and check. Yep, it's proper.
Yeah, just check for the Ganesha service on all of them.
Yes, I'll broadcast group service NFS Ganesha status stopped, and recheck the shared volume. Yeah, it's done.
It's on fine. Okay.
And
okay.
Yeah. Now let's do that setup again. Okay. Sir, feature dot Ganesha. Yeah, features dot Ganesha. On.
Enable. Forget it. It was fixed later. This is so bad.
This is so bad.
Take it off. It's fine.
It's fine. Okay.
That was bad, man. So bad.
I know. It's
what happened?
Shit. I think
it's not going everywhere. The 4 terminals, right?
I know. Why I don't know. It was it's going to 3. It's not going to 4th.
Yeah.
And the code down. That's the ultimate. Hey, just take it up if someone is watching it.
Oh my god, it's public.
Yeah, it just stop and